Welcome to a lesson with Dr. Powell. Let's keep going with this example of the top of a sphere that we've been discussing, the same one. But this time, let's look at a direct transferal into phi and theta and phi coordinates for the top of the sphere, where rho actually is just a constant, stays constant there. So what we're going to do is we're going to look at the different aerial projections that we have, dy, dz, dz, dx, and dx, dy. So these different components of the aerial projections vector. And we're going to just directly translate them into terms of d phi and d theta. How do we do that? We just use the derivative of the transformation. How we go from theta and phi to x, y, and z, so that the rise will be dx, dy, dz, and the run will be d theta, d phi. So if we want to be able to figure out how to write the rise in terms of the run, we simply make this computation here, this matrix computation, which is reflected in what we have here, dy. How do we get dy? Simply by taking this middle line dotted with that column right there, and that's how we get this dy. Similarly for dz, and likewise we get dx, which is represented right here. Now, whenever we have a double of things like d phi and d phi, we can ignore the double and we just go straight to what's different, the d phi and the d theta. Notice we get this right here after and we had the right order, d theta and d phi, so that's good. Now up here, notice, let's see, so we have basically what we're doing is we're taking this guy and we're multiplying it to that guy, kind of in a diagonal sense. In fact, you might notice a determinant type action happening here with a cross product type thing, like this cross that, and so you have a 0. Similarly for the next one, where you have like a 0 thing here, yet you have something there. But here, and here in this case, you actually have d phi, let's see, d phi first before d theta, so you have a switch. But it's the kind of same type of thing where this just distributes over the wedge, thought of as multiplication, just distributes over it to the different parts. And for dx, dy, similarly, here we have, it's kind of like we're taking outside and inside really as we do it, and in reversing directions or whatever else we need to do here, we end up getting this expression here, where we can actually factor out the d theta, d phi out of this particular expression. So we were able to, what does this show? We've been able to take the different components of the aerial projections vector and we rewrite them in terms of d theta, d phis, and that allows us to be able to factor out d theta, d phi out of the vector, and then when we find the length, we have a d theta, d phi multiplied to it, and then we just integrate that to find the surface area. So in the next video, we'll actually walk through the rest of the setup for this, but at least in this one, we've kind of seen how to rewrite the guys directly in terms of d thetas and d phis in such a manner. Thanks for watching.